All right, so we're on the back side of our ticket to retake. Number 6, the graph shows the cost of renting a karaoke machine. Kelly rents it at 9 a.m. Go ahead and circle that. That's important. That's the starting time. How much will she pay if she returns the karaoke machine by 2 p.m.? How much will she pay if she returns the karaoke machine at 2:10 p.m.? All right, so what we need to do is figure out how much time has passed. If we're going from 9 a.m. to 2 p.m., how many total hours is that? So from 9 a.m. to 12 is 3, 12 to 2, 12 to 2 is 2. If we count that up, that is 5 total hours. Now, what we'll do is we'll look at our graph over here. The x-axis is our number of hours. So we have 5 hours. Let's go over to 5 hours. So 1, 2, 3, 4, 5. Then we go up to our function. All right, so we have two options. One is an open circle, one is a closed circle. So which one of these is going to include um, our value of 5? Well, a closed circle includes it, an open circle does not. So this closed circle at 12 is how much it will cost if we rent the skates? No, karaoke machine for 5 hours. So this is going to be $12. All right, so what if they return the karaoke machine at 2:10? So how many hours is it? From 9 a.m. to 2:10 p.m. is 5 hours and then 10 minutes out of 60. So let's just say, I don't know, 5 and 1/6 hours, or that's about a 0.17. So let's go to the x-axis to a 5.17. So here's our x-axis, 1, 2, 3, 4, 5. 0.17 is going to be just a tiny bit bigger than 5. So we're a little bit bigger than 5. Let's go up to our function, and that puts us up here at this price point. So how much does it cost if we're right here? Let's see, this is counting by twos. 2, 4, 6, 8, 10, 12. That's going to be $14. All right, what is the average rate of change over the interval from 5.5 to 6? Well, we just did an average rate of change on the front page, and so now we know. We're going to circle rate of change. We're going to write the word slope, and then this interval for the x's, the first one is x1, the second one is x2. All right, so let's set up our ordered pairs. We have 5.5, comma, we'll have to see what the y value is. Then we have 6, comma, and then see what the y value is. So let's go to 5.5 for the x. So over 1, 2, 3, 4, 5.5. We go up to our function, that's 14. And then let's go over to 6 on the x-axis, 1, 2, 3, 4, 5, 6. Go up to our function. It's a closed circle, so it will include it, and that is also a 14. So rate of change, finding the slope, we're going to do y2 minus y1, so 14 minus 14 over x2 minus x1, 6 minus 5.5. That gives us a 14 minus 14 is 0 over 6 minus 5.5 is 0.5, and 0 divided by anything is 0. So there's our average rate of change right there. All right, number 7, Jill charges $12 for the first hour of babysitting and $10 for each additional hour or fraction of an hour. The rate that Joe charges for X hours of tutoring are modeled with the function shown below. All right, so let's label this. They told us that this was Joe, and then Jill, maybe we'll just circle, this is Jill's information. that whole first sentence. She's charging $12 for the first hour of babysitting, $10 for each additional hour or fraction of an hour. So the question is, who will charge more to tutor 4.5 hours? Jill or Joe, and how much more? So let's talk about Jill for a second. So for 4.5 hours, Jill's going to charge $12 for the first hour. So here's hour one. Hour two is now going to be, then she brings it down to $10. Hour three is another $10. Hour four is $10. So we're at to 4 hours total, but that 4.5, so at the 4.5 hour mark, it didn't go all the way to 5 hours, but we were told that she's going to charge $10 even for a fraction of an hour. So this is going to be another $10 right there. So we can total up what Jill would charge. We've got 10, 20, 30, 40, plus 12 is $52. So Jill charges $52 of babysitting for 4.5 hours. All right, so what is Joe going to charge? So Joe's function is a piecewise function where we have 3 different price points. He's going to charge $25 times every hour if we're babysitting between 0 and 3 hours. He's going to charge $15 times every hour if we're babysitting between 3 and 6 hours. And then he's going to charge $10 per hour if we're babysitting for more than 6 hours. So kind of like the longer you book Joe, the better deal you can get. So someone needs him for 4.5 hours. So where does 4.5 hours fall? Is that between 0 and 3, or between 3 and 6, or greater than 6? So 4.5 hours falls right here between 3 and 6, which means this 15x is the function we'll use to find what Joe charges. All right, so Joe charges $15 times x, which is our number of hours. The number of hours we have is 4.5. So the total amount that Joe charges is 15 times a 4.5. And that total is $67.50. So, question is, who's going to charge more to tutor 4.5 hours? Well, that's Joe. Joe's charged more. So Joe charges more. And then how much more does Joe charge? So if we take Joe's total, $67.50, and subtract Jill's total, $52, we'll see how much more Joe is going to charge. And that is $15.50 more than Jill. So Joe charges more, and he charges $15.50 more. All right, number 8. What is the equation for this graph? So if we take a look at our graph, well, it's a V-shaped graph. I can see that the vertex has moved away from the origin. It's now over here. And I can see that it got a little bit narrower. So let's identify what has happened out here. There we go. So first, the vertex moved. It was here. It went to the right 3, and then it went down 2. And so the vertex, if we went to the right 3 and down 2, that's positive 3, negative 2. And then what would the slope of this side of our line be? We're down here to negative 2. Can we just count the rise over the run? Up 2 over 1, up 2 over 1, up 2 over 1. So that slope of that right side, that tells us our a value is going to be a positive 2. All right, so our function, we can just use f of x equals, the structure of this, we always write the a value, which is 2, right in front of the absolute value bars. We're going to have an x first, and now is our horizontal movement. Well, we went to the right 3, but remember, this is going to be your x, which is tricky. We've got a tricky x. So should we say x plus 3 or x minus 3? Because it's a tricky x, we're going to say x minus 3. On the end is where we put any vertical movement. We went down 2, so we're going to say minus 2 on the end. And that's the equation of the graph. All right, number 9, write f of x equals 0.5 times the absolute value of x as a piecewise function. Okay, so let's talk about what's going on here. I think we can give ourselves a nice little visual to kind of make this a little bit easier. So the vertex of this absolute value graph, we don't have any numbers in here with the x. We don't have anything on the end. So the vertex is at 0, 0. This 0.5, our a value, is the same thing as a 1/2. So if we go up 1 to the right 2, up 1 to the right 2, we're going to get the right side of this v. And then we would do the same thing on the left side, up 1 to the left 2, up 1 to the left 2, and we'll get the left side of our v. All right, so this is an absolute value function, but it's also two lines put together at the vertex. We've got this line on the right that's going uphill. It has a positive slope. If you imagine the whole line drawn, we only kept part of it. We only kept this part of our line. So that's why we're not seeing this part, because we didn't keep it. Now, this other line, this has a negative slope. It's going down, and if you can picture the whole line, there's a whole line there, but we only kept part of it. So that's how it ends up being a piecewise function, is that we do have two lines, but we kept a piece of each line. So let's talk about what the equations of these lines would be. So on the right, here we have y equals, and I'm just looking at this line right here. So our slope, we went up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. So our slope is a positive 1/2 x. So I'm just thinking, y equals mx plus b. And then our b, our y-intercept, is right here at the origin. So I could put plus 0, but it would just simplify away, so we don't need to. So this is y equals 1/2 x. This line over here is another, let's get the equation of this line. We have y equals, now the slope over here is down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. So this one is going to be a negative 1/2 x, and then the y-intercept is 0, so just a negative 1/2 x. So those are the two lines we have, but we only kept pieces of them. So which piece did we keep here? Do you notice how right here at the origin, that is where this is where we kind of cut off and kept a piece. So this is when x is equal to a 0, right at the origin, right at the middle. That's where x equals 0. Well, over here on the right side, where we have our y equals 1/2 x, this is to the right of 0. So this side of our graph, that's where all your x's are greater than 0. And then over here, where we kept this piece of the line, this is on the left side of 0. So this is where all of our x's are less than 0. All right, now to put this together as a piecewise function, I'm just say f of x equals, we have our two lines. First we came up with the 1/2 x, and then we came up with a negative 1/2 x. So here's this line 1/2 x, here's this line negative 1/2 x. But we don't want the whole line, we only want a piece. So when we have y equals 1/2 x, which piece did we keep? This piece right here, for all the x's that are greater than 0. When we have y equals negative 1/2 x, that's not the whole line, it's just a piece. So which piece of the line did we keep? Just this piece, where all the x's are less than 0. So now it's looking like a piecewise function. The only thing we have to do is we have to consider 0. 0 is part of this absolute value function, right? That's where our vertex is. Over here, I did not include 0 in this line. See how I don't have the or equals to? And then I didn't include 0 in this line. It doesn't have the or equals to. So we just have to make sure that we include 0 um, in one of those. Not in both, just in one. So pick your favorite, the top or bottom. I'm just going to pick the top one. I just have to make sure one of those includes the 0. And there is our absolute value function or graph written as a piecewise function. All right, we have made it to our last problem. All right, so this is a piecewise function. We have this function, negative 1/3 x plus 3, that is slope-intercept form, slope of negative 1/3, y-intercept of 3. And then this on the right tells us which piece of that line we want to keep. Down here we have our line x minus 1, but we're not going to keep the whole line, we're going to keep this piece of that line. So let's just take this baby steps. Let's start by graphing this first line, negative 1/3 x plus 3. So I'm going to go up to, we got our y-intercept at 3. Our slope is negative 1/3. So down 1 to the right 3, down 1 to the right 3. And we're just sketching this in. Hopefully you guys are using a pencil and you're just going lightly. So this is that full line. But remember, we don't want the full line. We only want the line for the x's that are less than negative 2. So what we're going to do next is we're going to go to where x is a negative 2. So we're at the origin. Let's go to where x is a negative 2. Then we go to our line. So we're right here. This spot right here needs a circle, either an open circle or a closed circle, and this inequality tells us if it should be open or closed. So again, we want this line for the x's that are less than negative 2. So I'm at the origin, I go to where x is a negative 2, then we have to go find the line and we put a circle. That will be an open circle. Now we're going to keep one piece of this line. Do we want to keep the right side of the line or the left side of the line? And this tells us which piece to keep. We want to keep all of the x's that are less than negative 2. So which side has the numbers that are less than negative 2? To the right or to the left? And to the left has the smaller numbers. So we're going to keep this piece and we're going to erase that piece. All right, so we drew this function, but we only kept that piece. All right, now let's draw our next function. We have y equals x minus 1, so the y-intercept is negative 1. The slope is a positive 1. We lightly sketch in our line. And then we look to see which piece of that line we want to keep. We want to keep the line where all the x's are greater than or equal to negative 2. So let's put our pencil on the origin. Let's go to where x is a negative 2, and then let's go to the line we just drew, which means we're going to come down here. We need a circle right here, open or closed. This or equal to tells us to make that a closed circle. And then we're going to keep one piece of this line. Should we keep the left piece or the right piece? Now real quick, if we kept this left piece over here and I erased all of this, you would no longer have a function. It would not cross a vertical line test. But even in the directions, we were told that this is a function. So that's a good visual thing you could double check. Does our graph pass a vertical line test in the very end? So which piece of this line do we want to keep? We want to keep the piece that has all the x's greater than or equal to -2. So again, here's your x-axis, here's -2. All the numbers that are bigger than -2 are on the right side. All the numbers that are less than -2 are on the left. So we want to keep everything to the right of that circle. We're going to keep this whole part of our line, which means we're going to erase this whole part. And there is our piecewise function.